Okay students, so this is page 119 and it's example 10.7 and we're getting out the calculators for this example because it's just one designed specifically for the graphing calculators. Now it depends on what model you use. I've got an 83 plus here and it's an older model, and then I've got the high-end TI-89 titanium which can do everything, and in the middle I really need and wish I had a TI-84 or a brand new more expensive 83 plus because it can do a lot of things. So if you have one and you'd like me to make a video on how to work it, just let me borrow it some weekend and I'll definitely do that. But so I'm going to be kind of tag teaming these calculators because this guy, he's old, he's the base model, he's a little bit cheaper, so he's not going to be able to do absolutely everything, but we're going to try to get the most we can out of this base 83 plus. And what he can't handle, I'll bring in the TI-89 titanium, okay? Because I know one or two people sometimes have these titaniums with them. So we'll just kind of tag team it. Okay. So the first thing that you got to do in calculator stuff is, of course, enter your data into your calculator. Enter the x's into list 1 and enter the y's into list 2, okay? Or list 2, list 3. Enter them into separate lists. That's the main thing, and I've already done that, okay? I've already done that in both my calculators. So take a moment to, if you're going to work along with me, to do that. Okay, so number 1 says use a 1% level of significance to test the claim that rho is greater than 0. So this is a hypothesis test. So I've set up my 5 steps. Step 1, the hypothesis. Step 2, the p-value. Step 3, the p-value comparison, the decision, then the conclusion. Now this 83 plus can handle a hypothesis test, both a rho test and a beta test. It does it in the same click of a button. So what we're going to do is go to, well, we're going to turn it on first, aren't we? Then we're going to go to Stat. We're going to go over to Test. And we're going to go all the way down to linreg t-test. And there it is. And we're going to say the X list. I entered my data into list 1, and I entered my Y data into list 2, so that's fine. Frequency is always 1 because I do not have stacked data. It says beta and rho in your alternative. What's the symbol? In our alternative, it's greater than 0, so that's already been selected. That's great. The regression equation, I don't want that, but we want to calculate, and it's going to think about it for a minute. And here it comes. And notice it gives you the equation y equals bx plus a, or a plus bx, where b is the slope. And it confirms that you are testing a right-tailed positive test. It gives you your t and all that good stuff if you want it, and it gives you the equation of the line also if you would want it, which is handy. So I'm going to leave this information on my screen, and I'm going to use it to help me find my, sorry, trying to get that where you don't have glare on it, my hypothesis test information. So I'm going to use my arrow keys to scroll down. S in this is not the standard deviation, but it's the standard error of estimate, so be aware of that. These graphers, even though they might not be able to do some confidence intervals for you, they can give you SE, but they call it S, okay? Gives you the correlation, the coefficient of determination and the correlation coefficient, so it gives you both those things, all in one command. Now what am I looking for here? I'm looking for P, aren't I? P-value, there it is. 0.0179. I can put this to the side now, but I'm not going to clear off that information. I'm going to leave it hanging. Now, is P less than or greater than alpha? Well, technically P is greater than alpha, so we are going to fail to reject H naught at this level, meaning there is not a significant positive correlation between the X variable, whatever it is, and the Y variable, whatever it is, at alpha 0.01. Okay? Now for the equation of the line, I'm going to bring back my calculator, and I'm going to write down the A value, because they're giving me A plus BX. That's what I want. In other books, depending on your field, you might use the equation AX plus B It's the same equation, but they flip-flop the letter notation just because statistics isn't concrete on its notation yet. But in this book, in this course, we use a plus bx, where b is the slope. So I'm going to write down this equation. I'm going to write a negative 8.2934 plus the b, so I'm going to scroll down, find that b. There it is, it's 7.6760 times x. I'm going to put my calculator away to the side. Now I have my equation of the line, it's right there. Of course I have my conclusion, that's what I'd want to circle. Find the predicted pressure when x is 4. So I just write down my equation again. These graphing calculators really can make a lot of things very painless for you. You don't have to do a lot of calculating. And if you have a newer model, you have to do even less calculating because they have confidence intervals built in. So I'm going to go ahead and get to the bottom of my stuff. I can clear it out now if I wanted. I can always bring it up. It's not going to go anywhere. It's still in the calculator, the data. So it's not going to hurt if you clear it. You can just recall it. But I'm going to type in this equation and multiply it times 4 and find the predicted partial pressure when breathing pure oxygen. And it's 22.4106. And I believe that was mmHg over 10. And that's the same as we found before when we were doing it by hand. Same line that we found before when we were doing it by hand, same decision that we came to before when we were doing it by hand. So that's all of that, and this little base model could handle it all. Okay, the 83 base model can handle all that.